All right. So this week is going to be a little bit different than last week. Probably different than the past few weeks. I'm going to slow down a little bit. We're going to take a look at kind of some of the standards behind Linux and some of the cool things that it's not really cool. It's actually really boring. Compression files using tar and gzip and bzip and 7-zip. They're relatively boring, but they're also very important for backups, for installing new software from source. And I wanted to talk about really the standards that go behind Linux and how everyone's kind of agreed on the set of standards that make everything somewhat interoperable. There is the Linux standard base, which used to be one of the preeminent, and probably still is the preeminent standard when it comes to Linux distributions. It is the Linux standard base. It's a joint project from several Linux distributions. Primarily, this is sponsored by Red Hat and the Linux Foundation. And probably the biggest thing that everybody across almost every Linux agrees on is the file system hierarchy standard. Some of the less compliant things are like package management systems, a standard shell. There's also, it builds on an older standard called POSIX, which I think I talked about last week or maybe the week before. It's the Portable Operating System Interface, and it was particularly designed to make Unix systems more interoperable, and the Linux standard base is more or less an extension of POSIX and the single Unix standard. But it adds things, particularly, for example, X Windows. It adds a few other things like a common package format, which is RPM, and printing like cups and Fumatic. So it just makes Linux more usable for a wider audience. Unfortunately, there are only a few operating systems, a few Linux distributions that actually follow it. I believe basically the only one right now is Red Hat, but I could be wrong. I don't have a list of that in front of me, but I would suggest reading this stuff. I find it interesting. Some people find it really boring, but it's really the standards and the things that go in to making an operating system really polished. If Windows had 15 different companies that all had different Windows, and this isn't that far away from reality. Back in the early 90s, when Microsoft was working on a project called Windows NT, they were working on it with IBM, and as a result, IBM created an operating system called OS/2, which, if you look at it, looks a lot like Windows. It's a little bit different, but the thing that OS/2 was interesting, it was because Microsoft and IBM worked on it. And basically, that's where Windows NT came along. Windows NT was basically derived from what Microsoft got out of the OS/2 partnership, and was compatible with quite a few different Windows programs out of the box. And so you could kind of think of POSIX as a way to be like the bridging of like an IBM, AIX and like HP UX, which is HP's Unix. And the Linux standard base is a way for programs that run on, say, Fedora, would also work on, say, Ubuntu or Debian or Red Hat, Enterprise Linux. So they did that so that everyone could have a single standard to use. It isn't really being used. A lot of reasons. I think the Debian crowd kind of got not necessarily upset, but more or less bored with it. It was hard to comply because their system is a little bit different than Red Hat, enough to where there was limited compliance, and then just people stopped caring. And Ubuntu, which is based on Debian, also has dropped support very recently, just November of 2015. So I'm not going to go too in depth about what all this stuff means, but I really wanted to bring up this, the file system hierarchy standard, which is part of LSB, but more or less every Linux distribution agrees on this. Linux Foundation has really pushed it. Most Unix systems, they don't necessarily follow this, but some do. Like OS 10 is very similar to this. They have a few different variations, but for the most part, it's the same. But on any Linux system, pretty much you're going to see these directories. You know, the root of the file system, the primary hierarchy root, which is /. This is the root directory for everything, and you know that's kind of the root of the system. And in Linux, I also wanted to mention everything in Linux is a file or a directory, and all of the data on your system, like even to Linux, your screen is a file, your keyboard is a file, your mouse is a file, your network card, your speakers, everything is a file, and it can be a little bit daunting at first, kind of trying to wrap your head around that. It is true, but a lot of those files are special files, like device files, and you would find those in dev. And all of these directories are laid out so that it's easy to find things in every Linux distribution. There's bin, which is all your essential binaries are found. And there's boot, which is where your bootloader and your kernel is stored. Your kernel is actually the core of your operating system. Everything else is built around that. It's like the engine in your car, whereas this is kind of the nice leather seats, your GUI that you use, and then you have like the transmission, which is all the other programs. So this is where that's stored on the file system. Device files, like I was saying, like your screen, your keyboard, your mouse, this microphone that I'm using, they're all devices. There's etc., which is host-specific system-wide configuration files. Originally, in early versions of Unix, etc. was literally etc. It held everything that did not belong elsewhere. But etc. now is is exclusively used for configuration files. We've spent a lot of time editing files there. There are other directories inside of etc. And these are just the standard directories. This isn't describing every folder that's on a production system, but this just every system that runs Linux will have these directories in common. Then there's the X11 for X11 configuration files, which is the X window system, which is what we're using here. It's the GUI. Make sure everyone can see that. And then XML, configuration files, which is catalogs for software that processes XML. SGML is configuration files for software that processes SGML, and opt for add-on packages. Then home, which is where all home directories are stored. Then lib for libraries, and lib qual. This would be like if you have a 64-bit machine, you'll have a lib and a lib64 directory. Then there's media, which is your mount points for removable media like CD-ROMs, DVD-ROMs, Blu-rays, even some flash drives and stuff like that will be mounted in media. Mount is a temporary mounted file system point. This isn't really used automatically, but it exists so you can create mount points within mount if you want to mount a file system temporarily. And maybe next week we can go into file systems and how to mount them and what mounting them means, how all that works. Opt is for optional applications. These, generally speaking, are ones that you would install yourself through packages, which we'll go over. Not packages, but tarballs or tarballs, compressed tarballs, you would install probably to opt. I think we've done that with at least one. Was it Elk? We put an opt. Then there's proc, which is a place for other special files like processes. This is actually even programs that are running on your computer exist as files, as process files, and they would be running inside proc. Then there's root, which is the home directory for the root user. Run, which is runtime variable information. SBIN, which is system binaries. Serve, or SRV. This is site-specific data for services. Temp, which is where a lot of temporary files are stored. This is very similar to C Windows temp. Then there's the user directory, which ironically is for not user data, but for example, binaries. These would be programs you installed, like Firefox is likely installed in user bin. Include files. If you are a programmer and you use C, this would be where all of the C libraries would be for your include files would be. You have your library. Again, a libqual. This would be like if you had a 64-bit system, you'd have a lib64 here. A local. This is for just local data on the host. SBIN, share, source for source code. X11R6 for X11 configuration. Then var. And var is a very useful directory. This is where all your like log files are held in var. Lock files to keep track of resources that are in use and not in use. Lib, state information. Cache information for, it might be a system-wide cache that maybe a service uses or something else. You have user mailboxes here as well. Runtime variable information. Your spooler for, this would be for printing, for mail queue, stuff like that. And then another temporary file for preservation between reboots. And like I said here, most Linux distributions follow it. And they all kind of comply to it in different ways. Some don't use all of the directories. Some use symbolic links to keep compliance. For example, if I do an LL on, I can type. If I do an LL of just the root of the file system, it has a bin, but it's actually a symbolic link to user bin. And the same thing with lib and lib64. So basically, what a link is saying is, this directory exists, but doesn't really exist. It just points back to user bin. And same thing with sbin, lib64. This saves space so you don't have two different copies of the same thing on your file system, but yet preserves compatibility with the file system hierarchy standard. So it makes it compatible without really making it a pain to manage two sets of files in two different locations. Excuse me. So those are the big things I wanted to go over. I also wanted to talk about everything as a file. Now, unlike Windows, and we talked about this a long time ago, but unlike Windows, Linux doesn't care what file extension your files have. It doesn't care. It doesn't look at that. It doesn't really matter. But what does matter is it looks at the content of the file. And there's this, if you look at a binary file, let me see. We've done this before. We do file line tricks. It's a shell script, UTF encoded. And if I do a vim on that, you can see it's just text, and it's very readable. But if I go into, let's see, PyCharm, I think apparently I can't type. Okay, so there is let's do a file of FS notifier. And you won't have this on the system. I just have PyCharm on my system. And we can see that it's an ELF32-bit LSB executable, the Linux standard base. That's what that LSB is for. Let's actually go back to a system. Well, let's see which file. So file itself is a file called user bin file. So we'll do file user bin file. Again, it's a 64-bit ELF, which is executable linkable format. LSB, which is Linux standard base shared object. So it can be run. Let's actually do an LL of user bin file. You can see it can be executed by the permission here, the execute bit set. And if I want to see, if I do, I'm going to have to use the vim binary option to look at it. Otherwise, Vim will be very unhappy with you. You can see that it's just gibberish for the most part. Now, if you know a little bit about how executables are formed, it does look a lot less like gibberish, but it's still gibberish. But right here, it does say ELF at the top, and it also shows some of the things that are linked to it. Now, this isn't very helpful, and what the system uses, it uses the file, not exactly file, not the file command, but it uses the same information that file provides to determine what sort of a file that file is and what it should do with it. You know, for example, if I clicked on a file extension or a file that I had never opened before with anything, it would ask me what I wanted to open it with, and it wouldn't associate it necessarily with the extension, but with the type of file that it was. You know, it wouldn't just be like, oh, an exe gets run by Wine. It would be like, oh, Windows executable formats get run by Wine. And then if you had a Windows program with a .zip file name, it would still run. Now, generally speaking, for convention, it is important, not necessarily important, but it is good to include file extensions so that humans, you know, the wetware that can't be controlled by software, can actually understand what files are without having to open them up and see that it's some gibberish. Because if this file has no file extension, you know, in a Windows or a DOS system, this would have an extension of like a .exe or a .com or a oh no, those are the two. .com and .exe. But it knows how that it is an executable because it's got the execute bit, and it knows what to run it with because it's a file header, and the information provided to it similarly how file would do it. And this is important, especially if you get a piece of software, like for example PyCharm. It's not included in any repository. I had to go out and download it. And PyCharm is an integrated development environment for Python, for those of you interested. But I downloaded it, and it's just a binary that will run that program for me. But I had to download it, unzip it, and kind of install it by hand. And so, getting further on to the meat of what we're actually doing this week for the assignment is, gzip, bzip, 7-zip. I ripped this off from Dan. If you guys want to, definitely go here. He's got a very, very good detailed walkthrough on how to use gzip, bzip to 7-zip and tar. Generally speaking, when you're using zip files, or compressed files is a better term for it, with everything except 7-zip and, of course, zip, they operate on a single file. So in Windows, you can take and select a bunch of files and add them to a zip fairly easily. Now, there are two different operations performed by zip there. One, it creates a container or a box to hold everything in, and then compresses the box. In Linux, those are two different steps, generally speaking. You have tar, which takes everything and puts it in a box, and tar is short for tape archive. And then you use a compression program to take that box and compress it down. And those two formats existed independently of each other long before actually zip ever came around. If we look at the original gzip and bzip standards, they came around a long time before the original like pkzip and stuff like that. The deflate algorithm, which is an LZ77 mixed with Huffman encoding. Gzip was first publicly released in 1992. Maybe I'm wrong. Zip file format. Well, I lied. 1989. So ignore that. Gzip might not have been around, but there were plenty of others around that were very similar. I think bzip. Is bzip the one that's older? I'm going to prove myself wrong here. 1996, definitely. No, that's bzip 2. It was just Z format. Anyway, there was a previous, I think maybe it might have been deflate. Anyway, it doesn't matter. There were compression algorithms that existed long before zip did, and maybe it was deflate. Visually defined pkzip. Interesting. Did not know this. I'm lying to everybody here. Well, hopefully everyone has learned something here that don't always trust me. But what was the one before? It wasn't gzip. Was it LZ77? Don't remember, and honestly, it's doesn't really matter. There was a zip format in use long before zip, the zip file format itself, and I think it was just a .z, and I don't remember exactly what compression algorithm, but it existed in like the 70s and 80s. And tar was useful because you could take a bunch of files and put them into one file. It was a way to, particularly with tapes and writing two tapes, they needed a format because writing individual files were actually really, really slow. And it was a lot easier if you could put them all into a single file and write that single file sequentially to tape. It was relatively fast compared to, well, a lot faster than doing each file individually, especially if you wanted to take that file off the tape and restore it. Tars in themselves nowadays aren't particularly useful. Generally, you want to combine tar with a compression algorithm, and fortunately, that's built into the program itself. If we'll do a tar --help, everybody's favorite command should be --help. It goes over all of the different options. There is a option to compress, a option to gzip. It might have been compress. Also xzip, bzip2, lzip, lzma, lzop, which is just another format for LZ or for XZ, sorry. And a lot of different options in terms of compression. Now, if I just create a file, and I'm actually going to go back here, I'm going to make a directory, test, a cd test, and if I'm inside of my home directory, in a directory called test, and I'm going to copy a file here that we're going to play around with. I'm going to cp, well, actually, since we've been working with it, let's do cp user bin file here. And then let's also take etc. hdb conf.d owncloud.conf. Going back to there. So now if I do an ls, I should have the file command in owncloud. If I do an ls-l, I can see their sizes. Actually, if I do an LA, and not a H, LH, shows me that one's 24 kilobytes and that's 1.9 kilobytes. Now I can do a tar dash C. Actually, let me make sure my commands are right here. I think it's dash C for create. Yeah, dash C for create. The name of the archive, and then so CF, so create an archive, and then use a file called this, and then the files that you want to add to the archive. Let's do that. So I'm going to do a tar dash CF test.tar of file and owncloud.conf. Now if we do an ls dash LH, we can see that it's 30 kilobytes. If you take 1.9 kilobytes and add it to 24, it's actually less than 30 kilobytes, but because the tar file format itself takes up some room, and honestly, these files are really small, it wouldn't be that much overhead for any file of significant size. But we're talking about a 30 kilobyte file. That's uncompressed. That's actually bigger than the file that we put in there. And that would be great if I was writing to a tape drive. And for those of you who don't know what a tape drive looks like, let's do a reel-to-reel tape drive. Back in the old days, when computers were the size of rooms, this is what a tape drive looked like. They were huge. Then they got smaller. That's like about the size of probably a VHF. No, that's a lot bigger. That's still rack sized. This guy's dealing with tapes. Nowadays, their tapes are still around. Let's do LTO6 is the newest that I know of, and they're this size. They're relatively small, and these are huge, by the way. LTO6s hold about 6 terabytes in a single tape. They're big. They're really big. And I think LTO7s are even bigger. I think they hold 10 times as much or twice as much. I don't know if LTO7 hasn't been released yet, I don't think. But anyway, the tape drives are still around, and if I wanted to put this file on there, there's the native capacity and compressed capacity. And as time progressed, tar was like, well, let's make a file or a compression format, and let's just compress tar files because tar files are ubiquitous. Now let's create we can actually gzip this on its own. I'm going to do a gzip-help just to show you guys the different options. There's the options, and then file. Compress or uncompress files by default compress files in place. So I don't want to compress files in place. I'm doing a gzip. Let's say, can I do to different file? Apparently not. Well, that's okay. I'm not too attached to test.tar. Let's just do gzip test.tar. And so now that file size went down. Let's do an ls-lh again. It went from 30 kilobytes down to 9.7 kilobytes. It's bigger than owncloud.conf, but file was taking up most of the space. And now it's about half the size, or really a third the size of where it was. So compression definitely helps in terms of sending files over the internet, in terms of just saving disk space in general. Pretty much anything that you download will probably not be a tar.gz. It might be a .tgz or a tbz, or sometimes you'll see a .tar.gz. I could also have done this by doing, I'm actually going to do tar again. And we can just add a Z in there. And now you can see we have, oh, I just overwrote my original file. Oops, I meant to put test2 in there. Oopsie doodle. I was going to try to show you how they were the same, but now they're the same because, well, I screwed up. Let's do that again. Let's do a rmtest.tar.gz. I'm going to do a tar -cf of test.tar to file and oncloud.conf, and then I'm going to gzip test.tar. Now if we do an ll-h or an ls-lh, we see that they are the same. And even if I do a file of test2, it's a gzip compressed file test.tar.gz. It's also a gzip compressed data, but you can see that it was test.tar. So the only difference is one takes 2 steps, and tar, now that it has all those capabilities built in, I can just create compressed tarballs directly from tar. But it's important to know that they are 2 different programs and 2 different processes. It's just that nowadays tar has the capacity to send files to gzip to be automatically zipped when you create the tarball. And similarly, if we wanted to do, instead of a Z here, we'll do a test3. We'll use a different compression algorithm. I think it's J for bzip. Don't ask me why. Now, it's got a gzip file extension, test3 does, but you can see it's bigger. That's a little interesting. So let's look at that. File test3 tar.gz. It is bzip compressed data. Yay, I'm not lying to you this time. So that's bzip compressed data. I can also use, if we go back to tar and help, you can use a lot of different types of encryption here. Like I said, there's built-in xzip, 3 different ways of doing xzip. Now I can't find it. Oh, there it is, maybe. Yeah, right here, compression. One is for auto. I would probably not. Well, this is if you put the extension on the tar file, it'll automatically determine what to use. So if I would have done a .tar.gz with that A, it would have automatically created a gzip. If I would have put a .bz at the end of it, it would have created a bzip or an lzip or whatever. And they're all different formats. LZMA or lzip is a little bit different. We're actually going to install, I'm going to do a sudo-i to get to root, and we're going to install, first going to do a DNF search 7-zip. 7-zip is pretty cool. I'm going to do a DNF-y install p7-zip, and I'll do the GUI too, just for giggles. We'll go over here and go to 7-zip. This is based off of LZMA. And by the way, this works on pretty much every operating system there is. They have a Windows version here. LZMA is a compression format that I am particularly fond of. It's very good at compressing. And Let's do 7ZA help, because I don't remember 7-zip commands very well, because most of the time on Linux you're not using 7-zip, but 7-zip is useful still. So 7-zip command, archive name, file name. So similar. So let's do 7ZA add test.7z test to file. Oh, now that I've installed it, I can go back here. Sorry. 7ZA add. I wonder if it, what was the option again? Yeah, command. Okay, yeah, add. Let's do add test.7z. 7z is the extension for 7-zip. Add test.7z file and owncloud.conf. And it hates me. So let's do a 7ZA again and help. Let's see if we can figure out what our commands are. Oh, I was using the whole word A. It needs our add. It needs to just be A. Okay, so it put two files inside test.7z. If we do an LL-H for human readable, we have the bzip file, which I'm actually going to change the name of that. Move test3 to test3.bz, not gz, just so humans can know that it's not a gzip. And let's do an ls-h again. So our bzip is 10 kilobytes, our gzips were 9.7 kilobytes, and our 7-zip was 8.3 kilobytes. Now, these examples aren't exactly real-world scenarios, but you do have a binary file, which binary files, generally speaking, don't compress that well. And we have a configuration file, which is just text, which generally compress very, very well. So we do have a mix of file types and file contents, and it really helps to be able to see the differences between those in real world. And generally speaking, when you see file formats like this, of executables and text, they generally compress pretty well. Some things that don't compress well are things that are already compressed. Like if you try to take a zip file and zip a zip file, it's going to be usually bigger than the original. Same thing with like movies. If they've been used, if they've had an encryption algorithm, or not encryption, sorry, compression algorithm applied to them. For example, a DivX movie or a XVid or any basically media format that has video, they don't compress well because they've already had compression algorithms applied to them. And so they're generally already fairly small. And so if you try to zip them, you're really not going to get very good efficiency out of it. Oh, excuse me. Let me get some more sleep. So that's basically the end. We wanted to go over gzips, bzips, and 7-zips. Hopefully this is enough information. Help files are your friend, even for me. I've been doing this a long time. And I still require some tutelage when it comes to looking at help files and understanding exactly what commands do, because I don't use them all the time. I don't use 7-zip all the time, honestly. I do use tar quite a bit. I don't use gzip on its own at all. Oh, before I go, I do want to do one more thing, and that's I'll create another tar file. And instead of passing it inline to bzip, I'm going to create a test 4.tar. I'm going to do a bzip, and I definitely don't use it hardly ever. So we're going to help it. Okay. So I wonder if this could be, this should be able to just compress a file. Let's do it. Test4.tar. Yep, it did. So you can see these are the same file size now. The 2B zips are the same, the 2G zips are the same, and the 7-zip I can't really pass from tar directly because 7-zip actually includes its own box format, so to speak. And because zip and 7-zip weren't developed for tape archiving and not really used that much on Linux, they weren't, or Linux or even Unix, they basically kept the two intermingled, both having the format of the file and the compression algorithm itself. Whereas the Unix world and the Linux world had two different programs, one for the container, the format, like tar, and then another to compress. And those compression algorithms, whether it's 7-zip, bzip, zip, all those only operate on one file. It's just that 7-zip and zip have their own file that they also put them into. Hopefully that's clear as mud. But that's it. Send me a screenshot of, just like I did, I created a directory, put a couple files in it. I used file and owncloud.conf. Feel free to use whatever files you want. All I'm really interested in is seeing a couple source files and their file sizes, and then your compressed files and their file sizes. And just for giggles, also create a tarball, and if you can see, I want to see its size in relation to all the other sizes. So that's it for this week. Email me if you have any questions, comments, concerns, anything like that. We'll see you guys next week.